management and some frameworks around there to help with that. We're going to talk a little bit about routing and a tiny bit about styling, and then we're going to go into some of my own biased opinions. All right, so as we get into talking about the ecosystem, we have to remember that React just cares about the view, right? It's just the V and the MVC. It does not give you any opinions, does not give you any help with routing, models, views, stores, or sorry, it does give you help with views, models, stores, or even Ajax. It doesn't give you anything with Ajax, right? So we have to remember it's just concerned about the view. You got it? I think you got it. I'm sure this is what you feel like. So, so hard. None of them are hitting. So for handling complex data changes or state changes, right now you have about 4 options. We talked about one of them, and we're going to go through a few more. So the first one is setState. This is what ships with React. This is the way React handles state within any given component. And it's really great for smaller apps or really quick prototyping. In fact, I suggest if you're just getting into React and you're just fiddling around with it, just use setState, okay? It'll get you further than you think, and it'll give you results pretty much immediately. However, that being said, it can get pretty wild and hairy once your app gets more complex. That's because if you end up having 2 components in your UI, and when you change state in one component and it needs to affect a state in another component somewhere else, you end up having to send that state all the way up to its nearest common parent so it can travel all the way back down to that other component. And that can get really hairy as far as a mental model of controlling state. setState's great for tiny, small components that interact with each other, direct parents and children. Very nice. But as your app gets complex, you're going to want to do something else. However, I will say there is some evidence that this might actually scale well if you use this headache of sending state up and down through parents, if you use that as a constraint, if you use that to force yourself to not do it. You are thus just creating tiny mini apps for any given component that you make, right? So every app can be really self-contained, and there's a lot of potential for this thinking of creating extremely decoupled components to the point to where they just rely within themselves on what they need. But like I said, there's some evidence for that, but I haven't really seen it too much out there in the wild. And Facebook themselves have realized that using setState for everything is a problem as apps grow more and more complex. So they came up with this thing called Flux. Now, you may have heard of Flux, but it's important to realize that Flux itself is not a framework. Flux is rather an architectural paradigm. It's a way to structure your applications, somewhat similar to MVC, right? It's a way to structure your application to encourage what we call unidirectional data flow, one-way data flow, as opposed to two-way binding. And to visualize the differences here, we're just going to go into two-way binding at first. And this is what, we'd see in our traditional MVC with two-way binding. We get to the model, we end up getting to our model, and the model informs the view changes, the model changes. If the model changes, the view changes. They're just going back and forth, back and forth, back and forth. And this is an ideal representation of what two-way binding would look like. And if you can get every single view or module to look like this, then two-way binding can work very well. The problem is that as things scale up, a lot of times it ends up looking like this. And it's very hard to follow what's going on. You end up getting these loops, possibly, and you won't really know where to go, and you end up going down wrong branches of dependencies, and you end up feeling like this guy again. There's a chuckle. So, with Flux, instead of thinking in two-way data binding, we think of unidirectional flow for our data. And the two main things here are the action block here and the dispatcher. So actions and dispatcher. That's where the magic is actually happening. So what this is showing is that anytime an action happens on the view, Or anytime something changes on the view, it registers an action. An action is just a description of what the change, sort of like a meta description of what the change should be. So my action for the counter that I showed earlier might just be called increment, right? And then the dispatcher would take that action description, look within itself, well, would then send it to, it would look within itself and basically see if the increment exists, and it would describe what changes should actually happen to the store. And the store, via callback, would know when a change happens and apply that mutation to the store, which would then render out through your React and render out a new view. Now, I know that sounds complex, and I know that sounds a little weird, and maybe you might even be thinking this is a roundabout way of just doing two-way data binding anyway. But it's not. And the two key things here, for me at least, is that only one action can go through the dispatcher at a time. You can't have multiple ones going off all at once. And two, we have to remember that this is primarily for, at least for me, the reason I like Flux, is primarily for the debug experience. So when we go back to this and we think about debugging this, the issue is that when we end up following the path of our bug, we end up with a branch or a fork in the road, and we go, okay, well, I'm going to go down this way and see where this leads me. Maybe the bug's down here. And then we get another branch, we get another fork, and we decide, let's go over here. And then we hit a dead end, and we realize, crap, our bug wasn't over here. Let's go back down one more time. Let's try this route. That wasn't it. Let's go back down to the base and go back to the original fork, the original change to the model, to this other model. And you keep doing that, and it wastes a lot of time. With Flux, with this data flow, whenever you have a bug, you just follow one road. You're just following the action through the dispatcher, to the store, to the view, to the action, the dispatcher, to the store, the view. And it makes that experience as a developer a bit better. I'm not saying that Flux is a superior way of developing for performance or anything like that. I'm just saying that I personally think it provides a much better debug experience, much better developer experience, and better developer experiences create better apps. So, like I said, Flux itself is not a framework. It's just an idea of implementing unidirectional data flow through things called an action and dispatcher. An actual implementation of Flux architecture is Redux, and they say it's a predictable state manager. Now, if I'd given this talk a year ago, I would have like 20 different Flux frameworks to talk about. But luckily, this isn't a year ago, and it's pretty much just Redux now. There are other options like Reflux and Alt, but the community has really rallied around Redux as far as a Flux implementation. So if you're going to look for one, I'd say just look at Redux. It's become the de facto Flux implementation. Another cool thing about Redux is it doesn't actually depend on React at all. You can use Redux inside of Angular. In fact, I think someone early was somewhere mentioned something like that. So you can use it in other frameworks. It's just a way of handling data. And the thing that makes Redux unique as compared to what the original Flux sort of spec is that Redux is it carries your state in one single immutable data object, as opposed to many stores or many models. It just has one. And it's very, very, very explicit. You end up writing out each action by hand and describing what everything should do by hand. And there's a lot of boilerplate with Redux, I won't lie. But that boilerplate and that explicitness also makes it very predictable and easier to test against. If you want to get started with Redux, if you want to get a good intro to it, I suggest going to this link, or you can just search egghead.io for Redux. And the creator of Redux himself, Dan Abramov, gives a 30-course lesson on Redux. Each video is like 3 minutes long. It's really good stuff and very ingestible. So to visualize what Redux looks like against traditional Flux, here is a traditional Flux view. This is an edited view of that I grabbed off of the creator of Cycle.js. He does a lot of these kind of architectural views. Go check him out, stultz.com. But this is what a somewhat not very complex, actually pretty easy Flux implementation might look like. You have your actions, which go into a single dispatcher, and maybe the dispatcher has a change that affects two stores, and the stores put those changes into the view. Compare that against Redux, where you have your actions, which actually go into one store. And then within the store, you have things called reducers, and the reducers are what you define, is where you define the changes to your state. And what it ends up doing is using reduce. Reduce is a native ES5 JavaScript API that returns an immutable version of what was sent in, or it returns another version of what was sent in, right? It's immutable by nature. It doesn't actually mutate the original structure that was sent into it. It just returns a new structure with the changes. And then it sends that down to the view. So it's immutable by nature. Just using Redux, that's a core principle, is that it's one object and it's immutable. And this gives us a lot of cool things. When you combine immutability with a Singleton Store, you get extremely easy undo and redo. Or in other words, you get time travel. Because every time state changes, say you have your whole state object, state changed, I just created a new whole state object with only those changes. I've now got 2 instances of my entire application state available to me. I could do it again, and maybe I have 3 instances of my application state. I can now, since these are basically snapshots of my application at any given time, I can now travel between these 2. I can go back in time to a previous state. And that's really, really powerful, actually. If you want to see examples of this, just look up the DevTools for Redux. They're really, really amazing. You can just search for Redux DevTools. It also makes optimizing React pretty easy, because one of the ways you optimize React is through a lifecycle hook in any given React component called shouldComponentupdate. And all shouldComponentupdate is doing is it allows you to put in logic to decide whether or not a component should update at any given time. And that's very important, because remember, our React views are really just a representation of the DOM, and it's just a tree, right, of our view. And if we say this one component should not update, its children will not update either. So it's a way to stop re-rendering of any given component, which will speed up React's performance. And with immutability, it's very easy to just make a simple check between did this change or did not change. Also, the ecosystem with Redux is pretty massive. Like I said, the community is pretty much rallied around Redux. And so a lot of the edge cases you might come across, or even if you think the boilerplate is too much, there are community solutions to these things. You've got things like Redux Dux, which is a way of writing Redux to reduce a little bit of boilerplate, or a way to structure things. You got Redux Saga, on the other hand, which can help with certain calls. There's a ton of them out there. Just look them up. You can just type in Redux and you'll find all the other plugins out there. And what's really nice about that is that since Redux itself doesn't rely on React, a lot of these Redux plugins themselves don't rely on React either, or they have ways around it, so that you can use them in an Angular app or what have you. But for real, go look out those Redux DevTools, because once you scroll down and you look at those diffs and you realize what this Singleton Store with immutability can do with time travel, you're going to look like this. That's the biggest one yet. All right. So that's Redux. I have to talk about another one here, though, and that's MobX, or Mobix, or whatever. It's pretty much the newcomer to this whole how do you handle state in React. The thing it has over Redux is that it's way more automatic. It's not as explicit. You don't have to write out every single action. You don't have to go into your dispatcher and write out what's mutating, because it doesn't actually use immutability at all. It's actually mutating. Not the actual DOM, it's mutating values, so that React would then make the diff. So what it uses is observable values. So if you have an observable value and that changes, you have other values that are observing that value. So if this one changes, then its dependencies change. And that's how MobX basically works. And it handles a lot of things for you. It's a lot more magic. And a lot of people are finding that they like this more than Redux because they're able to get up moving a lot faster than with Redux. Because like I said, Redux has a lot of boilerplate. However, it is newer, so it doesn't, the ecosystem surrounding it isn't as large. I'm not 100% sure how many edge cases have been solved for it, so I don't know how robust it is in really large apps. And because it's less explicit, it might mean possibly that it's less predictable than Redux, although just about anything you use is less predictable than Redux because Redux is extremely predictable. So that's MobX. I can't talk about it too much. It's still pretty new, and there's not a whole lot of use cases out there showing it. But definitely check it out if you want something that's not a Flux implementation, or you think Redux is a little bit too much boilerplate or too much to handle. Check out MobX. That might be what you're looking for. The other option here is GraphQL and Relay, and perhaps also mixed with setState, depending on what you do with GraphQL and Relay. It was also developed, both of these were also developed by Facebook, and they were developed explicitly to work with, well, Relay was developed explicitly to work with React. And Relay is sort of an interface between React and GraphQL. It sort of interprets things and hydrates the data and does stuff. If you're using React, you're using GraphQL, you're going to use Relay in the middle. But GraphQL itself is a query language, which means it is a direct competitor to REST. Okay? So Facebook created their own REST, and they called it GraphQL. That's not to say you can't technically wrap GraphQL around REST APIs. It's just the optimal happy path is you just use GraphQL. Relay depends on GraphQL. So the buzz around this is that for React apps, this really could be the future. A lot of preliminary working on this looks like it is extremely fast because it does a lot of neat things with caching on the client side. It also allows you to define your data for any given React component as a schema, as a graph, or almost a JSON-like schema right next to your component. So it makes it really easy to know what your component's using or what's inside of it at any given point in time. But it's also extremely new, and there's only technical previews out there right now. I haven't seen, there are some frameworks out there that are trying to make it easier to use on things like Java and Python. Oh, and that's another thing. GraphQL is a query language. It's not just front end. You have to get your back end developers in on it too and tell them, hey, we're not doing REST, we're doing GraphQL. So it's a little bit too much commitment, I think, right now to really invest heavily in, unless you're doing a really greenfield project that you want to be on the cutting edge or bleeding edge, because you might hurt yourself. Who knows? All right, so those are the options that are out right now for handling data or state with React. As far as routing goes, you can technically use whatever routing solution you want. Like I said, you can drop React into Angular and use Angular's routing. It's possible. You only really need client-side routing for single-page apps, though, as we talked earlier. The most popular solution is React Router, and I wish I could give you guys another React router or React-based router to suggest, but it's really the only one out there that is React-specific. I've seen some people mention Router 5, but as far as this is the router that you should use for React, you really only have one choice, and I really wish there was more competition here, because I can't believe that one team there's not just one right way to do it. There's many right ways to do many things. So I'd really like to see another router out there that is React specific come out and gain popularity. But for now, React Router is where you're going to find all the documentation. That's where you're going to find the community. That's where you're going to find the Stack Overflow answers. So just use React Router is probably my suggestion. If you're building a fully React app and not plugging React into something like Backbone or Angular. As far as styling goes, because we are messing with the view, you can technically use whatever you want. You can use it with normal CSS. You can use it with less. You can use it with Sass or whatever. You can attach class names. You can send in a style object into it. It's whatever you want, really. However, there is a trend going to make styles more modular and reusable, the same as components, so that they're very similar, so that you have. So what this has given rise to is a lot of inline style solutions, and in particular, a lot of CSS in JavaScript solutions. So you have things like Radium, JSX styles, JSS, a handful of other ones out there that are CSS inside of JavaScript. And there's an argument there to be had that you get the power of JavaScript for calculating certain things and keeping variables and things like that reusable without having to use something like Sass or less, but rather just native JavaScript, which you're already programming in anyway. That's the argument for it. However, if you don't want to use one of those, you could use something like CSS Modules, which is basically you still write in just regular native CSS, or you can even use it with Sass. You can use it with whatever you want, really, especially if you're using Webpack to build, which I think we had a talk on that just a couple months ago. And what CSS Modules does is it basically allows you to use class names within your application, within the developer experience part of your application. You can use the same class names over and over and over and over without them conflicting. So if I have two components, just like a button component and a search component, and within the CSS files that live next to them, both of them could have a class named .base or .start or whatever you want, .green or .success, right? They could both be the same class name. You can't do that with regular CSS because whichever one ends up at the bottom is going to overwrite what's up on top. You end up having to do these important rules, and it's just not possible. What CSS Modules allows you to do is use the same class names, so your developer experience is really nice. You can look at your CSS in context with your component, and what it does is basically just create a hash at the end of the class name, so none of the class names conflict. It's pretty ingenious, actually. So that's how you can get modular styling to go along with your React components. You don't have to do that. It's just a trend that a lot of people are going towards.
So is that through JSX? Or?
It has nothing to do with JSX necessarily. It is, like I said, you don't have to use JSX for any part of React. What you would do for styling on top of a React component is the same way you would style just about anything, really. It's either a class name or inline styles, right? You either have, think of an HTML element. You either have class equals class name or style equals inline styles. One little asterisk there in React is it's not class, it's class capital N name equals. The reason for that is class is a reserved keyword in JavaScript, and you're writing in JavaScript. So, and you could do it without JSX. It would just be part of the props, part of the data that you send into that component.
So does React manage that hash at the end of the class name that you're talking about?
No. So the hash at the end of the class name is CSS Modules specifically. So if you want to, you can just look up CSS Modules, and there's some really good examples of it. It's easiest to use with just a Webpack build because you can just add it as part of your CS style and CSS loader, and it's just a query. You just put in a question mark and put modules 1, 2, or whatever, something like that. It also works with Browserify, but it's something you have to compile with. It's not like native CSS. Just like with Sass, you have to have something that compiles it. All right, so now on to my suggestions and biased advice on how and when you should use React. So when should you try React? And I would say if you've got a Greenfield project, something that you're just starting up from scratch, give it a shot, or at least do a quick prototype to see how you like it if you haven't used it yet. Or if you want to use it in a legacy product, if you want to use it in a product that's already out there, use React, but make sure you use it in small incremental view layer refactors. remember what I said, like it can be patched into most frameworks relatively easily. There are, like I said, for Backbone and Angular, there are a lot of tutorials out there for how you can do that. But no one is saying that you should rewrite your existing app in React because React's the coolest thing ever, right? That's just bad advice for everyone. You don't have to do that if you want to try React on your product. You can do it incrementally and still ship to production, okay? Also, this may seem obvious, but React is best when it's driven by APIs. At least I haven't seen it inside of anything like Java JSPs with Spring or anything like that. Like, I don't think you should try that. As long as your front end is API driven, React will be a good fit. So how should you start using React? I first would suggest to go to this GitHub link, petehunt/react-how-to. He was one of the members of the original Facebook team. He's no longer at Facebook, or React team. He's no longer at Facebook. But he has a nice README about what he suggests about how you should start getting into React. And this is basically what he says. For the simplest prototyping, you can actually start using React to try out with inside of CodePen, JSBin, JSFiddle, or if that's not big enough of an editing area and you want to use your own IDE or whatever, you can actually just create an HTML file and use a JSX transformer in the head of your HTML. So you just call it in. There's, I think, Babel-standalone, I think, is one. And Facebook also has its own JSX transformer, although I don't know if they maintain it anymore. It's been a while. But you can use both of those in browser so that all you need to do to start writing React code is just script tag, start writing React. You don't need to have any of this internal plumbing with Webpack or anything necessarily to start writing React code. As far as, like I said, as far as using state stuff, just use setState at first before you get into Redux or MobX or anything, because the plumbing required to set those up is going to discourage you before you actually make anything that excites you, I think. And only dip into GraphQL and Relay if you really want to be on the bleeding edge and you have the time to really do a lot of research and poking around yourself without too many resources out there to rely on. However, to get the benefits of a full React app, you will need something like Webpack or Babel in your build toolchain somewhere, or Browserify. If you really want to reap the full benefits of things like server-side rendering and all that, you're gonna need to have something like that in place. So we're almost to the end here, and maybe throughout this talk you're like, I like certain things that you talked about React, but I hated this other thing about React. So maybe you're one of the very, very few that just likes JSX and you hate the rest of React. You can actually do that. You can actually bring JSX into a non-React application with native JSX and that repo there. If you like the virtual DOM, but you hated everything else about React, you don't like the component aspect of it, but you want a virtual DOM, you can use just the virtual DOM. If you like the components of virtual DOM, but you hate JSX and you want to use ES6 template literals, you can use T7. If you think React is too heavy, because it is a little bit large as far as payload goes, you can use something like Preact, which is basically a lighter weight React. It takes out some of the checking, some of the heavier, safety things that React has, but still has the same API. If you want something that's similar to React but different, you can check out Deku and Mithril. They have very similar concepts as React. All right, so in conclusion, React is great. It enhances developer workflow, I think, through declarative UIs, composable, building composable UIs. It brings us loosely coupled, highly cohesive, reusable components. It has a really large ecosystem around it, and the community is really gathered around it to support it. And it does one thing and one thing well. It only cares about the view. But It only cares about the view. It will not help you with anything that's not the view. Thanks. I don't know if we have time for questions.
Yeah.
If there are any. No?
That means it was a really good presentation.
Or a really bad one. All right. It's only about the view. Thanks, everyone.